The quantum computing race has become a two-horse race between tech titans IBM and Google, and the stakes couldn't be higher. Google's Willow breakthrough grabbed headlines with quantum error correction, while IBM's Nighthawk quietly delivers real-world quantum advantage to enterprise customers. This isn't just about bragging rights. It's about controlling the future of computing and the $850 billion quantum market. Elon Musk's reaction to Google's Willow announcement. I've heard from a few people now that quantum computing is showing real promise. Captured the moment when quantum computing shifted from theoretical possibility to inevitable reality. But while Google celebrates quantum supremacy demonstrations, IBM is building quantum systems that solve real business problems today. The question isn't who can build the most impressive quantum computer. It's who can build the most useful one. Google's approach to quantum computing focuses on achieving quantum supremacy, demonstrating that quantum computers can solve problems that classical computers cannot. Their Willow chip represents a breakthrough in quantum error correction with 105 qubits that become more reliable as the system scales up. This achievement validates the theoretical foundations of quantum computing and proves that large-scale quantum computers are possible. Google's quantum supremacy demonstrations are scientifically impressive but practically limited. Willow can solve artificial problems designed to showcase quantum advantage. But these problems don't correspond to real-world applications that businesses need. Google's strategy prioritizes scientific breakthroughs over commercial utility, positioning them as the research leader in quantum computing. The technical achievement of Willow cannot be understated. Google demonstrated that quantum computers can solve problems in 5 minutes that would take classical supercomputers 10 septillion years, longer than the age of the universe by a factor of 700 million. This exponential speed-up validates the theoretical promise of quantum computing and proves that quantum advantage is achievable. However, Google's focus on quantum supremacy creates a disconnect between their technical capabilities and market needs. While Willow can perform calculations that classical computers cannot, these calculations don't solve problems that businesses are willing to pay for. Google's quantum computers remain primarily research tools rather than commercial products. IBM's quantum strategy prioritizes practical applications over theoretical demonstrations. Their Nighthawk processor with 120 qubits and 5,000 gate capability is designed to solve real-world optimization and simulation problems that businesses face today. IBM's quantum cloud platform serves over 200 organizations worldwide, creating a growing ecosystem of quantum applications and developers. HSBC's breakthrough with IBM quantum computers delivered measurable business value, a 34% improvement in algorithmic bond trading. This wasn't a laboratory demonstration or artificial benchmark. It was a production-scale financial algorithm running on actual market data generating real profits for HSBC. IBM's quantum computers are already creating economic value, not just scientific papers. IBM's enterprise-first strategy creates sustainable competitive advantages through network effects. As more organizations use IBM quantum systems and develop quantum applications, the platform becomes more valuable for all users. This creates a virtuous cycle that reinforces IBM's market position and makes it harder for competitors to displace them. The cloud-based delivery model allows IBM to scale quantum access without requiring customers to build their own quantum labs. Organizations can integrate quantum computing into their existing workflows through APIs and cloud services, lowering the barriers to quantum adoption and accelerating the development of quantum applications. The technical approaches of IBM and Google reflect fundamentally different philosophies about quantum computing development. Google pursues quantum supremacy through specialized quantum processors optimized for specific algorithms, while IBM builds general-purpose quantum systems designed for diverse applications across multiple industries. Google's approach prioritizes quantum purity, building quantum systems that maximize quantum effects and minimize classical interference. This approach enables dramatic quantum speed-ups for specific problems, but limits the practical applicability of their systems. Google's quantum computers excel at problems designed for quantum advantage, but struggle with the messy real-world problems that businesses need to solve. IBM's hybrid quantum classical approach recognizes that practical quantum computing will involve seamlessly integrating quantum and classical processing. Their quantum systems are designed to work alongside classical computers using quantum processing for specific computational tasks, while relying on classical systems for data management, user interfaces, and result interpretation. The IBM-AMD partnership to develop quantum C-centric supercomputing represents the future of high-performance computing, hybrid systems that leverage the strengths of both quantum and classical processing. These systems will tackle problems that neither quantum nor classical computers could solve alone, creating entirely new categories of computational capability. The business models of IBM and Google reflect their different approaches to quantum computing. Google treats quantum computing as a research project that may eventually generate revenue, while IBM treats quantum computing as a commercial product that must generate revenue today. This difference in perspective shapes everything from technical priorities to customer relationships. IBM's quantum venture investments demonstrate their commitment to building a quantum ecosystem. By investing in startups that develop quantum applications and tools, IBM is creating a network of partners that extend the capabilities of their quantum platform. This ecosystem approach creates switching costs for customers and competitive barriers for rivals. Google's quantum business model remains unclear. While they've achieved impressive technical milestones, they haven't demonstrated a clear path to monetizing quantum computing. Google's quantum research is funded by their advertising business, creating a disconnect between quantum achievements and business results. The market response to Google's Willow announcement, a $50 billion increase in quantum computing sector valuation, demonstrates the financial impact of quantum breakthroughs. However, this market enthusiasm may not translate into sustainable business value if quantum achievements don't solve real customer problems. The quantum race between IBM and Google is intensifying as both companies approach critical milestones. IBM's roadmap targets fault-tolerant quantum computing by 2029, while Google continues pushing the boundaries of quantum supremacy. The next 5 years will determine which approach, enterprise utility or scientific supremacy, wins the quantum market. The competitive dynamics are complicated by the different success metrics each company uses. Google measures success through scientific publications and quantum supremacy demonstrations, while IBM measures success through customer adoption and business value creation. These different metrics make direct comparison difficult, but also suggest that both companies may succeed in their respective approaches. The IBM versus Google quantum race represents more than corporate competition. It's a battle over the future direction of quantum computing. Google's research-driven approach advances the scientific foundations of quantum computing, while IBM's enterprise-focused strategy accelerates practical quantum applications. The quantum computing industry benefits from both approaches, but the market will ultimately reward the company that delivers the most value to customers. The winner of the quantum race may not be determined by technical superiority alone. Success will depend on building sustainable business models, creating valuable customer relationships, and developing quantum applications that solve real-world problems. Both IBM and Google have strengths in these areas, but their different strategies suggest different paths to quantum leadership. Which company do you think will win the quantum race? Is Google's scientific approach or IBM's business focus more likely to succeed? How will quantum computing change the competitive landscape in technology? This is Click Future, where your future is a click away. Share your prediction in the comments below and subscribe for continued coverage of the quantum computing revolution.